Okay, looking at question number 1 of the 2021 AB and BC exam, and I've already worked this problem once, but for some reason it did not record, or that's probably my fault. So you get a rehearsed answer this time. The first time was a more me thinking through the problem, but we have a table of values that gives you the density of a bacteria population in a petri dish. The table gives you values of R and F of R, where F is the density measured in milligrams per square centimeter. And question A is a very predictable, nice question. When you have a table of values, they ask you to approximate F prime of 2.25, and we will approximate that by finding the slope of the 2 points that sandwich 2.25. So we're going to find F of 2.5 minus F of 2 over 2.5 minus 2, which would be 10 minus 6 over 2.5 minus 2. And if you want to clean that up, that does simplify to 8. There's no need to do that, except you need to clean it up or be able to determine if this is positive or negative, because the next question asks if using correct units, interpret the answer of that. So I found out that F prime is positive. So my basic interpretation is F is increasing. So that's my thought process, but we have to say in words what F is. So I go to my paragraph, and it describes the function F as the density of the bacteria population. So I would say the density of the bacteria population at time is, so that's a big sentence saying F. So F is increasing at approximately 8, and the units, and this is an interesting unit, but if you look at the units on top, we subtracted 10 and 6, which are milligrams per square centimeter. So that's milligrams per square centimeter. And then in the denominator, we subtracted 2.5 and 2, which are centimeters. So that would simplify to, or be rewritten as milligrams over centimeters cubed if you want to. No need to change that. So the density of the bacteria population is increasing at approximately 8 milligrams per centimeter cubed at time T equals 2.25, not time, when the radius. So when it's not time, R is equal to 2.25 centimeters. There we go. Forgot my C. So let's look at question B. The total mass in milligrams of bacteria is given by this expression, 2 pi, antiderivative from 0 to 4 of R F of R. And this is a really interesting one. They want you to approximate this using a right-hand Riemann sum. And what you have to remember is the function we're using is actually R times F of R. So it's not, it takes a little bit more thinking here. So we'll approximate that using a right-hand Riemann sum. The 2 pi is not part of the Riemann sum, so I'm going to just leave that out there. And we have to use 4 intervals going from 0 to 1. My delta R, which is the base of your rectangle, is 1. And then my function value, I'm finding the area under R times F of R. So at the right end of that interval, my R value is 1, and my F of R value is 2. So we have to remember to do R times F of R. It's not just the Y value, which it typically is. So interesting little twist on this one. My next interval from 1 to 2 is also a base of 1. And the height is R F of R, which will be 2 and 6. My next one from 2 to 2.5 is a base of 0.5. And my R value is 2.5 times my height at 2.5, or my function value at 2.5 is 10. F of R, or F of 2.5. Plus, and then from 2.5 to 4 is a base of 1.5. My R is 4, and my F of R is 18. And I would leave it like that. I'm not going to do anything else to that answer for fear that I might fat finger the calculator or do something that will cause me to lose points. So I'm done. They did not ask you to include units. If you wanted to, they tell you that this does represent the total mass in milligrams. So they imply the units in the question, but you should not need to include units on this one. So number C, is the approximation in part B an overestimate or an underestimate? So for part B, we found a right-hand Riemann sum, and in the paragraph, they described the function f as a an increasing differentiable function. Now, we didn't find the area under f alone. We found the area under r times f of r, but that will ultimately be an increasing function. And if you do have an increasing function, a right-hand Riemann sum will always give you more area than is actually contained by the graph. So I'm going to explain why r times f of r is positive or is increasing. You could find the derivative through a product rule, but that's going to be a little bit overkill. I'm simply going to say this. Since, or I'll say r and f of r are both increasing, on the interval 0 to 4, therefore, r times f of r is increasing, making a right-hand Riemann sum, a right Riemann approximation, and overestimate. There we go. And then part D, the density of bacteria in the Petri dish for 1 to 4 is modeled by this function g. So now they introduce a function g. They say for what value of k is g of k equal to the average value of g of r. So the average value of g of r on 1 to 4, that part is going to be easy. 1 over 4 minus 1, integral 1 to 4 of g of r. So I'm going to find the average value. And we'll do that in the calculator. So let me pull up my calculator here. Let me clear all this out. This is from problem number 2, I believe. So control B. Let's plug that function in. So it was, it's over here. 2 minus 16 times the cosine of 1.57 square root of r. Shoot. I need to go back up here. I need to, is it cube that? I need to cube that function and double check, make sure everything is in there correctly. It is. So there that is. And I want to find the average value of that. And it was from 1 to 4. So control divide, 1 divided by 4 minus 1, which is 3. Antiderivative 1 to 4 of f1 of x dx. I'm going to get that decimal answer. And I'm not through. That's not my final answer. So I'm going to store that for A. So I got an average value of 9.875. 9.8757. And I'm going to store that in my calculator for A. And now they ask you when g of k equals that average value. So I need to solve g of k is equal to 9.8757. And we'll solve that in the calculator. So I'm going to go back to my graph screen, go up here, and I saved that value for A. So I'm just going to graph a horizontal line at y equals A. I can't see it right now, but I will once I adjust my window. So my window settings, we are entering only on the interval 1 to 4, and I'll take my y's from 0 to 10. That will get the value that I need. Oh, just barely. I want to give myself more breathing room. Seems like I shouldn't be that close, should it? Whatever, there. I want to make sure I got that in there right. Oh, it's 9.85. I was thinking 8 point. Okay, so yeah, it should be that close to 10. Whoops. All right, so menu, analyze, intersection, and Tadao, 2.497 would be the value of k, for which g of k equals its average value on 1 to 4. And so there is question number 1 of the 2021 AP AB exam.